Hi, and welcome again to a new piece of Semantic Kernel, in which I'll describe how Semantic Kernel can be used even as a simple API wrapper to simplify calling API like the API of Azure OpenAI or OpenAI. And in this clip, I'll show you how you can use the multimodal functionalities of OpenAI. So you can pass an image to the prompt and getting a description out of the image from the prompt. And I want to show you how easy it is to use semantic kernel. Very few lines of code. You don't need to know how the API are structured. It is very, very easy. As you can see, I have a simple notebook, standard polyglot notebook. I've changed it a little bit and I've moved to .NET 9. I fixed my version of semantic kernel because semantic kernel moves on and sometimes it breaks some dependencies, it breaks some interfaces. So I'm going to fix for this example. And then so we can restart the kernel, and absolutely you just install the dependency with Nugget. Once the dependency are installed, we are using the simple configuration where I'm going to use my account of Azure OpenAI, and I'm using a GPT-4o Mini. And then I get a reference to the interface chat completion service. That is the base interface that allows you to interact with the chat model configure. So this interface allows you to contact the Azure OpenAI with the chat interface. And then there's a little trick show into this code. And this is because I'm going to ask a short description and a long description for an image. And usually when you are using a model like GPT for multimodality, for image processing, one of the standard use I have is getting an image, pass it to the GPT, and get a description where I want the model to extract specific information of the image. Sometimes I just need a short or long description. Sometimes I need a description contextualized, like I'm giving you an image of a mechanical piece of something. Could you please describe this piece as thoroughly you can? Or can you identify if you have some animals in the image? And so I want the answer of the large language model not being a textual answer that I need to parse. I want it to be a JSON answer where I can take different part of the image. So in this simple example, I want a short description and a long description. And the easiest way to force GPT or other large language model to answer a JSON is using tool or function calling. And thanks to semantic kernel, this is really easy to do. As you can see, I simply have a lambda, a simple lambda function in which I use 2 parameters, and the lambda function does nothing, so it returns nothing. It serves only to me to define the format of JSON I want in answer, in response. So if I want a specific JSON, I use a different parameter for the function, and each parameter is it has a description. So semantic kernel knows how to put those description into the API call. So the large language model will be forced to call this function. And thanks to the kernel function factory, I can simply create a kernel function that is a representation of the function in the space of object of semantic kernel from a simple lambda. And then I need to use a specific setting to call, when I'm going to call the large language model, you need to do a required function choice behavior. It does mean that the answer of the large language model must always abide to the function declaration. And the auto invoke, clearly, it needs to be set to false because the function does nothing. It does not return anything. It's just a trick to say, hey, I'm going to tell you, I'm going to ask you something, and in result, you need to give me the parameter that I will use to call this function. I will never call this function, but thanks to this, I have the answer of the large language model parsed for me, and so I can immediately access short description, a long description. Now, a little bit of disclaimer. Unfortunately, semantic kernel let slip some specific call of the specific LLM you are using, and that's unfortunate. I think things will change in the future, but for now, I show you that you can use a prompt execution setting to specify which function to call. But let's say you want to change the temperature of the calling, okay? Temperature is a standard parameter of all large language model. If you're using Azure OpenAI, that it's an OpenAI model hosted by Microsoft in Azure, you need to use, unfortunately, new OpenAI prompt execution setting. So you need to pass the settings specific to the model you are using. So that is a little unfortunate, because if you're going to change the model you are using, you probably need to change this. But I show you in a future video that you can use some trick to avoid this. In this situation, you can use max token, you can use temperature, and the function choice behavior is the very same option. So nothing changes. You can use the OpenAI prompt execution setting for doing the very same call. Then you have the section in which you can specify that you want an image to be contained in a prompt. So you need to use the standard chat history object that allows you to create a chat history. The first message of the chat history is a system message in which you give the context, you give the system message. And it's something you are an expert technician that will extract data from images. And then I simply need, with this code, to create an object that is a read-only memory byte. It's a class of semantic kernel. You just need to read all the bytes of the image, so you don't need even to care about the format. It supports PNG, JPG. And then once you have the image data, you create the chat message content item collection, in which you specify a text content, and it's a description like extract a short description. These are the specific instructions for this image. And I want you to extract a short description and a long description. And then you specify, and that's the text content. And then you simply specify the image content. So it's a simple chat message in which you have a sequence of answer, response, answer, response. You can put as many pieces of text and image you want, and this will simulate a chat. And if you just wanted to extract something from the image, it is enough to say, use a text prompt that gives the context, that gives the instruction, and then the image content, and that's all. You see, it's very, very simple. Now, once you have your message, you can simply add it to the chat message, and that's easy. It's just add user message. And then you use the get chat message content sync function of the chat completion service, in which don't forget to pass the OpenAI settings. And this settings contains max token output, it contains temperature, but what is most important, it contains a function tool behavior that force the large language model to use the function I showed you before, the one that has short description, a long description. And now you can just press play and see what happens. Once you call the get chat message content async, you got a result. And since you specify the setting that force the large language model to use function calling, you can cast the results and say, from all the answers of the large language model, I'm interested only in the function call content. And so you can have the function name, and the function name is the only function you got. But what is important, you have a dictionary of argument in the fcc.argument. So everything is already parsed for you. So I can simply say argument short description. It's okay, that's the short description of the image. Then you have argument long description. So as you can see, with this kind of helping from semantic kernel with very few lines of C# code, you can use any model that uses the tool function calling like GPT. In this situation is GPT O-mini, but you can use GPT O, O1, O3, whatever you want. And you can use, with very few lines of code, a model to extract information from a function. And that's different from using a simple OCR to extract text from a function, from an image. In this example, you are using the powerful multimodality feature of large language model to have the model describe the image for you and giving a context in how you want the image to be described. This is a simple example, short description or long description, but you can ask whatever you want. Is there a person in the image? Can you identify the gender of the person in the image? Is there an animal in the image? And whatever you want. And it's pretty fast. As you can see from the example, I have a 5 seconds call for the image, and in 5 seconds, I got the answer. So it's pretty much quick. And the description is pretty much interesting because I've simply taken a screenshot of website where I'm downloading the .NET 9, and it absolutely recognized this as the image display, the SDK version and ASP.NET Core runtime version. So it's pretty much powerful, even if this is smaller model, GPT-4o Mini. To conclude, we can use model like GPT multimodality to analyze an image, ask to the model whatever you want to extract from the image. These models are pretty much powerful. In very few seconds, you get an answer. And thanks to Semantic Kernel, you can use very few lines of code to obtain the result. And you can also use Semantic Kernel tool calling facility to have the answer forced it to be a JSON, and Semantic Kernel is gonna parse the JSON for you. So you just create a dummy function that has the arguments, dummy arguments that represent the data you want, and everything is done for you with very few lines of code. Really powerful function of Semantic Kernel. Bye-bye, I'm waiting you for the next video.